Hi ladies and gentlemen, this is Ms. Skokin. We have two learning targets for the next lesson. The first one is use a two-way table or a Venn diagram to model a random process and calculate probabilities involving two events. And the other one is apply the general addition rule to calculate probabilities. Can you taco tongue and evil eyebrow? So the taco tongue isn't exactly shown by the emoji. It's when you can roll your tongue. And the evil eyebrow is when you can raise one eyebrow without the other. Some people believe that the ability to taco tongue and evil eyebrow is something that you were born with. Is this true? Are the two abilities somehow related? We're going to collect some fake class data, since this is a recording and we're not in class together right now, to fill in the following two-way table and Venn diagram. You may remember that a two-way table is when we have two variables that are represented, one in the columns and the other one in the rows. You've also probably seen Venn diagrams in the past. We're going to be using the Venn diagram to help us calculate different probabilities. So let's get started. So imagine that we were all sitting in class together, and all together there are 30 students. And what we do is we ask which students are able to do the evil eyebrow and which students can do the taco tongue. And we ask everyone to raise their hands. So let's say there are 5 students who can do the taco tongue but not the evil eyebrow. And there are 15 students who can do both the evil eyebrow and the taco tongue. Let's say there are 3 students who can do the evil eyebrow but cannot roll their tongue in the taco tongue format. And there are 7 students who can do neither. So now what we're going to do is we're going to add up the columns, and we end up with 18 and 12. We add up the rows and we end up with 20 and 10. And of course we knew our grand total was going to be 30. Now what we want to do is represent this on the Venn diagram. So let's start out with where they can do both the taco tongue and the evil eyebrow. On the two-way table, the both is represented by the 15. And so our sets, which are representing on the left-hand side the people who can do taco tongue, and on the right-hand side the ones who can do evil eyebrow, the intersection of our sets, which is this area represented by, sometimes they call it the football area. Anyhow, that is where we represent both, where these two sets overlap. Now, when it comes to the people who can do the taco tongue but not do the evil eyebrow, and that's 5, a grand total of 5, they go here. When it comes to the people who can do the evil eyebrow, so they fit in the evil eyebrow circle, but they cannot do the taco tongue, they would belong here. So in the part of the circle that does not overlap with taco tongue. The neither category, which goes outside the two circles, that is 7. And those are the people who cannot do taco tongue and not do evil eyebrow. Now you'll notice that there are 4 areas in the Venn diagram. And those 4 areas correspond to the 4 cells in the two-way table. Now that we've got the two-way table and the Venn diagram filled out, we can start calculating some probabilities. Now, just one note, one of the things that I like to do with Venn diagrams is put on the outside of it the universal set, which in this case is a grand total of 30 students. So it's just something that helps me figure out exactly what my total should end up being. If we show probability in the Venn diagram, which is something else that we can do, then of course the universal set, or the whole box of the Venn diagram, would total up to a 1.0. Okay, let's take a look at number 2. Suppose that we randomly choose a student from class. Find the following probabilities. Now the fact that we're choosing randomly from the class means that our denominator is going to be 30, because that's the total number of the students in the class. How many are yes that can do taco tongue? So what we're going to do is go to the taco tongue row in our Venn diagram, and we see that we have 20 students who can do the taco tongue. So that corresponds to, on the Venn diagram, the red area plus the yellow area, because that encompasses everyone who can do the taco tongue within that circle. Okay, when it comes to no taco tongue, then that's going to be the complement or the balance, and that's going to be 10 out of 30 students cannot do the taco tongue. The next one is find the probability of yes taco tongue and yes evil eyebrow. That means they can do both, and that gives us our 15 out of 30 that we see in the yellow area on the two-way table in the Venn diagram. The next one is they can do the taco tongue and not the evil eyebrow, and that's the red area that we see on the Venn diagram. So that's going to be 5 out of 30, or on the two-way table, the red area. The probability associated with being able to do yes evil eyebrow is the grand total for, or the total, column total for evil eyebrow, which is 18, divided by the grand total of 30. No evil eyebrow, of course, is the balance or the complement of that, so that's going to be 12 out of 30. And that's the total of the no evil eyebrow column divided by the grand total. When it comes to yes evil eyebrow and no taco tongue, then that's going to be what we might call evil eyebrow only, which is 3 out of 20. And then the last one is no taco tongue and no evil eyebrow. So that's the one that they can do neither. We've shown that in the green areas. So that's going to be 7 out of 30. Now notice we've shown all of these probabilities as a fraction. We could also show them as a decimal or as a percent. Any of those formats is acceptable. However, it's always a good idea to start out with the unsimplified fraction. Okay, now let's just take a look at number 3. Again, we're going to randomly choose a student from class, and we want to find the following probabilities. So yes evil eyebrow, we found that a few minutes ago, and that's 18 out of 30. And then no evil eyebrow is 12 out of 30. And these, you may remember, because they cannot happen together, are called mutually exclusive events. And when we combine them, yes evil eyebrow or no evil eyebrow, that means that we're going to add those two together. So probability of A or B is equal to the probability of A plus the probability of B, which means when we substitute in 18 out of 30 plus 12 out of 30, so those two mutually exclusive events add up to 1, because that includes everyone, or 30 out of 30. Let's take a look now at some non-mutually exclusive events. So we'll start again with the probability of yes taco tongue, and that is 20 out of 30 according to our two-way table or Venn diagram. We also know based on our two-way table and Venn diagram that the yes evil eyebrow is 18 out of 30. Okay, now what about when we want the probability of yes taco tongue or yes evil eyebrow? Now, we might think that because we know the probability rule, when we use or, we add them together, we might say that this is going to be yes taco tongue is 20 out of 30 plus yes evil eyebrow is 18 out of 30. But if we add those two numbers together, we're going to get 38 out of 30, which is above 1.0 or above 100%. So that's really not possible. Now, when we look at our two-way table, we can see the 20 and the 18 actually intersect where we have this 15, or another way of thinking about that is they overlap. In the 18, the 15 is already counted. In the 20, the 15 is counted again. So we need to subtract out one of those 15s so we don't double count it. And we will do that right here, minus 15 out of 30. Now this allows us to calculate the probability of yes taco tongue or yes evil eyebrow without double counting where they overlap, the people who can do both the taco tongue and the evil eyebrow. And that means we have 20 plus 18 minus 15, which is 23 out of 30. And we have just developed the general addition formula of probability. And that says the probability of A or B is equal to the probability of A plus the probability of B minus the probability where they overlap, or probability of A and B. As I said, this is called the general addition formula. And we had an addition formula before, but we couldn't use it all the time. We could only use it for mutually exclusive events, where this one works for all events. Let's fill out our box of important ideas on the next page. Our first learning target was all about calculating probabilities from two-way tables and Venn diagrams. I'm going to set it up with a simple two-way table with two values of each of the two variables. And the values are going to be A and not A, B and not B. And let's just label these areas 1, 2, 3, and 4. Now let's set up the Venn diagram and number the areas that correspond to the areas or the cells in the two-way table. Both goes in that football area. Neither goes on the outside. A and not B goes in this area, and B and not A goes in this area. Once we've got these both set up correctly, it's very easy to calculate those probabilities. Let's talk about the general addition rule now. Formally, in probability notation, the general addition rule reads, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that means where they overlap. We talked about an addition rule before for mutually exclusive events. And if events A and B are mutually exclusive and they can't occur together, then the probability of A and B is equal to 0, and that would then reduce down to the probability of A or B is equal to the probability of A plus the probability of B. This brings us to the check your understanding problems, and this will give you a chance to practice using the two-way table to come up with a Venn diagram, as well as explaining in interpretation of some of these probabilities. So go ahead and finish this up and then check on Canvas for the correct answers. Make any corrections that you need to in your own notes, and I'll see you back in class.